Hey everyone, we are going to cover lesson 17.1 and we're not going to open the book today. We're just going to do notes and examples and we'll open the book a little bit later. So let's take a look at graphing these two, and I'm just going to walk you through this and then you'll have the note sheet and you can use Kami or you can print it off. So first, if I'm looking, this one is not in standard, or this is in standard form. It's not in slope-intercept form yet. So I need to solve for y by subtracting 3x from both sides. So y equals negative 3x plus 9. So if I graph this, I'm going to plot my y-intercept at 9. And my slope is a negative 3 over 1. So I'm going to go down 3 boxes over 1, down 3 over 1. And make sure you're going in the correct direction so that your line is decreasing. And then I'm going to connect these. Make sure we're always using a ruler so that our line is straight. Then my next one has a y-intercept of 2, and that's already in slope-intercept form. And this slope is a positive 1 over 2, so I'm rising 1 and I'm running 2. And this line is increasing. And then let's connect this one. Oops. And what do we notice? We notice that they intersect, and they intersect right here. Okay, and that intersection point is over to 2 on my x-axis, up to 3 on your y-axis. All right, next, the first one is already in slope-intercept form. So I'm going to graph my y-intercept at negative 3, and the slope here is up 2 over 1. It's positive, so my line's going to be increasing. Down 2 over 1, down 2 over 1. And make sure you put as many points on your coordinate plane as possible because we don't know where these lines are going to intersect. Okay, so put as many points on your line as possible. And then for my second one, it's not in slope-intercept form yet because this y is not alone. It's being multiplied by 2, so I need to go ahead and divide everything by 2. And notice that I do not have to shade anymore because I do not have inequality symbols. Okay, I do not have inequality symbols. I'm going back to equal signs. So our two learning targets are solving a system of linear equations by graphing and then interpret the solution of a system of linear equations. So before I even graph, I notice that this is the exact same line. So I'm at negative 3 and I'm going up 2 over 1, up 2 over 1. So what do they have in common? They're the exact same line. So they don't intersect once, they intersect the whole entire time. They're the same exact line. They have the same slope and they have the same y-intercept. Okay, for this next one, first one's in slope-intercept form. I'm up at 6. And I'm going up 3 over 1. It's a positive slope. I can't go up 3 over 1 anymore, so I want to go down 3 boxes over 1 the other direction. I want to put as many points on here as I can before I draw my straight line. Oops, that was a little off. The next one is in standard form, so I want to convert it to slope-intercept form. So I want to get 2y alone. So add 6x to both sides. 2y equals 6x minus 8. Divide everything by 2. That cancels. Y equals 3x minus 4. So plot my y-intercept down at -4. And my slope is up 3 over 1. So what do we notice here? These lines are parallel. Ooh, they never intersect. Why? Because they have the same slope. Okay, so on your note sheet, we can start filling in our notes. So let's talk about systems of equations from activity 17. So lesson 17-1. Systems of equations are 2 or more equations with the same variables. And usually when we're graphing, we use x and y. Sometimes if there's a story problem, we might use something else. Graphically, it's the point xy where our 2 lines intersect, and that's what we're going to do in lesson 17-1. And then in 17-2 and 17-3, we're going to look at how to solve these algebraically, and that's the point that makes both equations true. So if we have intersecting lines, like this, that means there's one solution, and we write it as an ordered pair, x comma y, and that was the first example that we did. If we happen to have parallel lines, either with a positive slope, that's the example I'm going to draw, then there's no solution, and you can write no SOL, or sometimes it looks like this, no solution. And then if it happens to be the exact same line, so I'm going to draw a line, and then I'm going to go like this to make it look like the same line coming out. Then it's infinitely many solutions, or sometimes I write IMS, or here's the infinity symbol, whatever you prefer. So let's walk through the steps to solve systems by graphing. Step 1 is to convert to slope intercept form, which is solving for y, so y equals mx plus b, and this is only if necessary. Sometimes we don't need to. Step 2, we need to graph both lines. And step 3, identify the solution. So let's start graphing these. The most important thing to remember is a positive versus negative slope. Okay, think about Mr. Slope Dude. If your slope is positive, your line needs to be increasing from left to right. You're going uphill, up the ramp, up the mountain. If your slope is negative, your line needs to be decreasing or declining from left to right. Okay, so step 1 is to convert both of these to slope-intercept form, which is y equals mx plus b. But that's already done for us. Okay, so I'm just going to start by graphing this first one right here. My y-intercept, my b value is -8. So your graphs do not have numbers on them, so just assume that every box is 1. So start at your origin and count down 8 boxes. And then our slope is a positive 1/1. So go up 1 box, over 1 box, the whole way. I don't have to worry about solid versus dotted lines, and I don't have to worry about shading anymore. It's really important that you're using your ruler and making your lines straight so that we can see a good intersection point. Then my second line, we have a y-intercept at +1. My slope is a negative this time, so my line is going to be decreasing down 2/1, down 2/1, down 2/1. There's my intersection point. Remember, your x coordinate comes first and then your y when you're writing your solution point. So in and out of my elevator. So I go over to 3, down to -5. Okay, and I want you to keep going. You can do question 2. These are also both in slope-intercept form, so you don't have to do any converting. Just go ahead and plot your y-intercept. You're not going to get decimals for these answers. You should get whole numbers.